Hello everyone, grade 9 mathematicians. Welcome to our first video on rational exponents. So again, these are numbers with exponents in a rational form or fraction form. Like this, for example. So the base is 256 and then the exponent is a fraction or is in a rational form. Okay, so how to handle these numbers? Okay, this is what we're going to do. So we have some notes here. Write the base as the radicand. Okay, so let me introduce to you to this kind of number. Like for example, square root of 2. So the square root sign is called the radical sign. And the number inside it is radicand. Okay. So if we have a number expressed in this form with fractional exponent, here are the steps. So write the base as a radicand. So we are going to write the radical sign and then the base becomes the radicand. Okay, now let's focus on the fractional exponent. What will happen to the numerator? Yes, that's correct. The numerator becomes the exponent of the radicand. So we write exponent 1. And you are correct. When we have an exponent 1, then we can just keep it invisible 1. Okay. And then the denominator, which is 4, becomes the index. So what is the index? That is the small number at the corner of the radical sign. So we call this fourth root of 256. So what do we mean by fourth root? So we are going to identify a base that when raised to 4, okay, will be equal to 256. So basically, when we have fourth root operation, we'll be thinking of a number multiplied by itself 4 times will equal the radicand, 256. So what number is that? So what we can do is start with a smaller one. So we can have 2 to the 4th. What is 2 to the 4th? That is 16. And then how about 3 to the 4th? That is 81. So probably it's 4 to the 4th. So multiply 4 times. So again, the expanded form of 4 to the 4th is 4 times 4 times 4 times 4. So pause the video and try to multiply 4 times. Alright, so you are correct. 4 to the 4th is 256, and that is our radicand. So the fourth root of 256 is 4, which means that the number multiplied by itself 4 times, that would equal to 256 is 4. So we can have this 4 to the 4th is equal to 256. And you can always validate your answer using math way. I will introduce math way. Okay, we can integrate the classical way of solving with the calculators, and it would be great to be at par with the calculators. But I would really want to see solution, okay? Because it's really in the solution that I can see, or we can see, that you understand the process, and also if you explain the steps or provide a solution walkthrough. Okay, so we have 256. We just have type here 256 and then the correct here, and then 1/4, and then go, and then simplify, and the answer is 4. So your final answer is correct. Then you just have to show your solution. Number 2, so we have 144. Okay, converted to a radical number. Again, radical numbers are numbers with the radical sign. So the first thing we need to do is write the radical sign or the radical symbol. What is the base? Yes, it's 144. Again, the base becomes the radicand. So the radicand is 144. The numerator of the exponent becomes the exponent of the radicand, and since it's 1, then we can just keep it invisible. And then the denominator becomes the index. Again, the index is the number at the corner of the radical sign. Now, if we have 2 as an index, we can also keep it invisible. So again, if the radical symbol does not have an index, it's an invisible index, then it is understood that the index is 2. So again, the radical symbol without an index is called square root. Alright, so this is now square root of 144. So let's now recall our perfect squares. What number multiplied by itself is equal to 144? Okay, so make sure that you memorize the perfect square. So the answer of this is 12. Okay. Now let's have another case, and we would be able to apply our laws of exponent. What did you notice in the given? So we have 2 factors. So this is multiplication of 2 numbers with the same base. So what are we going to do? Product rule? Yes, we copy the base. And what are we going to do next? We add exponents. Alright, so we close it with parentheses. So we have 1/4 plus 1/4. So it's time now to review our operations on fraction. So this is similar fractions. So we're not touching the base. So we copy it. And then 1/4 from plus 1/4. Copy the common denominator. And then add numerators. 1 plus 1 is 2. And then simplify. Simplify the fraction, lowest terms. So, base is 900 and the lowest term is 1/2. Now is the time to write this in a radical form with the radical symbol. So, write the radical symbol. The base becomes the radicand. Numerator becomes the exponent of the radicand, and the denominator becomes the index. So what is the square root of 900? So think of a perfect pair with perfect squares. So because our index is 2, then we think about perfect squares. Okay, so break down 94, we'll do factor 3. Okay, so break down 900 into 2 factors that are perfect squares, or at least 1 factor that is a perfect square. But In this case, 900 can be broken down into two factors, 9, a perfect square, and 100, a perfect square. Okay, so we are now going to rewrite 900 as 9 times 11. So we have square root of 9 times 11. Okay, and now we can perform the square root of the two factors inside the radicand. So once we have two factors inside the radicand, perform the square root operation to each factor. So we're gonna do square root operation twice. First one is square root of 9 is 3. So write 3, and then perform again square root operation to the second factor of the radicand, 100. So square root of 100 is 10. Now we have 3 factors here, and we don't have the radical symbol anymore. After performing square root operation, then we don't have the radical symbol anymore. Okay, and then 3 times 10 is 30. Alright class, so in this next case, we are going to apply again product rule. We have common base 625, so copy common base 625 and then add the exponents. So we have two dissimilar fractions. Alright, so kind of scary. I know that there is a process for dissimilar fractions. Alright, we're not touching the base, so just copy it. Alright, so how to handle dissimilar fractions? So make it similar. Okay, so most likely the new denominator is the bigger denominator. Alright, the bigger denominator is 16. Ask yourself, is 16 a multiple of 8? Or is 8 a factor of 16? Or divide. Divide the GCF, 16, the bigger denominator, by 8. 16 divided by 8 is 2. Okay? So, in other words, since 16 is a multiple of 8, then the bigger number 16 will be the GCF. Okay? So, most likely, if the smaller number is a factor of the bigger number, then our new denominator will be the bigger number. Okay? And we're not changing the denominator of the first fraction, then we just have to copy the existing numerator of the first fraction. And then copy the plus sign. Now we are going to think of the equivalent fraction for 1/8. How to do that? Okay. Divide the new denominator, that's 16, with the old denominator 8. So 16 divided by 8 is 2. And then multiply the quotient 2 with the old numerator 1. So 2 times 1 is 2. So the equivalent fraction of 1/8 is 2 over 16. Alright, so copy now the base, 625. And then we have 4 over 16. And then we do lowest term. And then finally, convert the number with fractional exponent into radical number, that radical form. So square root sign, or the radical sign, and then base becomes the radicand. Numerator, exponent to the radicand, and the denominator becomes the index. So we are being asked of the fourth root of 625. Pause the video and think of a number multiplied by itself 4 times will equal to 625. Okay, so the fourth root of 625 is 25.